Good morning to all. Today we are going to present about the Project 2, Sleep, Health and Lifestyle. And I'm Dr. Yu, and my teammates are ZHENG and also ANGIE.
This is the dataset we have been using in testing. We use heart rate on hypothesis 1 sample test because we have some constant that have different average heart rate in population from the commonly accepted average of 70 beats per minute. For hypothesis 2 sample test, we have to use gender and heart rate because we have to see the significant difference in the average heart rate between the male and female. For correlation, we have to use the sleep duration and stress level from 0 to 10 because if you have enough sleep, you can reduce your stress.
Okay, for the high school test of independence, we are going to use the quality of sleep and also the BMI categories. Okay, for the BMI categories, we have 5 categories, which are the normal, underweight, obese, and also the underweight. Okay, for the quality of sleep, also the rating from 1 to 10 toward the quality of sleep of the respondent. Okay, these two are chosen because we want to prove that the quality of sleep will affect the BMI categories. Okay, for the regression, we are going to use the physical activity levels and also the step. Okay, the day step is the step of each person every day, and the day activity level is the activeness of each people to do the physical activity. It's because there is existing research that claim that daily steps tend to increase with the physical activity level due to the factors such as they need to walk and run when they are attending a physical activity.
The null hypothesis that the population mean heart rate is equal to 70 ppm, and the alternative hypothesis that the population mean heart rate is not equal to 70 ppm. So we're using one sample t-test to calculate the following. The t-value is 0.56729, and the degrees of freedom is 149. The p-value is 0.5714, and the 95% confidence interval for the mean heart rate range from 69.55 to 70.81 ppm. Since the p-value is greater than the significant level, which are 0.05, we fail to reject the null hypothesis. This means that there is not enough evidence to conclude that the mean heart rate of the population is different from 70 ppm. The null hypothesis that the population mean heart rate of male is equal to that of female. The alternative hypothesis that the population mean heart rate of male is not equal to that of female. So we're using two sample t-tests. We calculated the following. The t-values is negative 0.91375. The degrees of freedom is 132.36. The p-value is 0.3625. The 95% confidence interval for the difference in mean range from negative 1.80 to 0.66 ppm. Since the p-value is greater than the significant level, which is 0.05, we fail to reject the null hypothesis. This means that there is not enough evidence to conclude that the mean heart rate of males and females are different. The mean heart rates of males and females are not significantly different. Correlation is used to find the relationship between the sleep duration and the stress level. The correlation coefficient is equal to negative 0.821851. It's so that the strong negative correlation it can get from the result of the programming. And here is the scatter plot. It's showing the relationship between the sleep duration and stress level. As you can see, there is a clear negative slope indicating as the sleep duration increases, the stress level will decrease. So our hypothesis are as follows. The null hypothesis that the population correlation coefficient is 0. The alternative hypothesis that the population correlation coefficient is not 0. And we use the programming to get the following value. The test statistics is equal to negative 17.55. The degrees of freedom is 148, and the p-value is less than 2.2 times with 10 power of negative 16, and the significant level is 0.05. So since the p-value is much less than the significant level, we reject the null hypothesis. There is sufficient evidence to claim that there is a negative strong relationship between the sleep duration and stress level.
For regression, we have used the physical activity level and the daily step. From our programming, we can get the test statistic is 70.223, the degree of freedom is 148, and the p-value is less than 2.2 exponent negative 16. Since the p-value less than significant level, which is 0.05, so we can reject H0, which is the null hypothesis. The scatter plot between daily step and physical activity level has shown in the slide. From this, we can see there's a weaker positive linear relationship because the plot in the graph is gathering but not tied. So we can prove that if we have more physical activity level, then our daily step will become higher.
Okay, this one is a high school test of independence. Okay, for the hypothesis, we test that HCO is BMI categories are independent on the quality of sleep, and the H1, the BMI category, are not independent on the quality of sleep. And you can see this is the graph of the distribution of the quality of sleep across the BMI categories in our data. And according to the observation, we can see most of the normal have a 8 quality of sleep, which have a quite high quality of sleep. And for the people with overweight, you have a quality of sleep in around 6. So now we are going to test whether that is independent or not independent about the two of the relationship. Okay, here is the high school test of independence of the result. So we can see the two-way contingency table are generated by the R programming. Okay, the total is already shown, and also the vertical is the BMI category, and the horizontal is quality of sleep. And of the frequency are already shown here. Okay, in the significant value of the alpha is equal to 0.05, and the degree of freedom, we get the degree of freedom 15, so that the critical value we come from the table is 24.996. Okay, from the high school value with the test statistic are also calculated by the R programming with 95.653. Since the test statistic value are bigger than critical value, we have sufficient evidence to reject the H0 at the significant level of 0.05, so that we can say that the high school tests are not independent to the quality of sleep. Thank you.